Hi, my name is Nathan. It's Saturday the 27th. It's 20 past 6 nearly. So this is going to be another entry in my I Was Thinking series. So I've been doing videos on mental illness, but this is gonna be a new one. So this is gonna be on global warming and climate change. So this is gonna be I'm gonna carry on doing the mental illness videos, but like this is a new one that I'm new series that I'm starting in the I was thinking series. So, firstly, the reason why I wanted to talk about climate change and global warming is because I wanted to understand what it actually is. I wanted to do my own my own little investigation into trying to understand what it is. Apart from just throwing words out there interchangeably. So all the yeah. I was gonna write down like a list of things that I wanted to like. This is just gonna be like an intro. So what I wanted to understand. Or what I was thinking about global warming and climate change. So for starters, I'll just talk about my assumptions on what my assumptions are on global warming and climate change. Actually, that would be a good start. Okay, so I think the words global warming and climate change they're used interchangeably. So I'd say global warming is a phenomenon and climate change is something that happens regardless of whether humans are here or not, because the climate changes every single day, every month, every year, thousands of years, millennia, millions of years, whatever. And global warming is like it's in well, I wouldn't say, well, I could call it a phenomenon. I could also call it an effect as well, and it's an effect that happens naturally, I'd say, and it's been hyped up to the point where it's hard to try and try and look at it without looking at the human cause human side to things. So when I come to like trying to understand what climate change or what the climate actually is, so I'm trying to understand what the climate consists of. In my head, I was thinking that okay, the climate consists of the atmosphere. So what is the atmosphere? So what is the atmosphere? How big is the atmosphere? Um, where does it start? Where does it finish? What is in the atmosphere? So how so like the atmosphere has several layers. Like you've got the ionosphere, you've got the normal atmosphere, then you got the stratosphere, then you got the troposphere. Then I think you've got like an ionosphere, and then you've got like a magnetosphere as well. I think. Yeah, I need to have a look into that. And so the higher you go, there's less air, there's less oxygen, which is basic physics or yeah, basic atmospherics really, basic physics, basic science. The higher you go, there's less air, less oxygen, the harder it is for you to breathe. So I'm wondering how do you calculate how the Earth's atmosphere actually is? What is the volume of the Earth's atmosphere? So, which is what I wanted to start with. So how do you work that out? So do you start off at sea level, or does it start off at sea level and then does it end somewhere like a couple of miles above the Earth's surface or what? Because let's say the Himalayas is like 5 miles tall, um, which is like 8,000 feet, I think. Yeah, something like that. 8,000 or 9,000 feet. But you have airplanes that go like multiple times higher than that. So like let's have a look. Let's have a look how where does Earth's atmosphere start and finish? Okay, so I'm just gonna go look into Wikipedia. Where does the atmosphere end and space begin? World Atlas as well. So let's look at two different websites for now. The atmosphere of Earth is the layer of gases commonly known as air, retained by Earth's gravity surrounding the planet Earth and forming its planetary atmosphere. The atmosphere of Earth protects life from creating pressure allowing for liquid. Okay. By volume, okay, so this comes into the elemental composition of the Earth's atmosphere. By volume, dry air contains 78.09% nitrogen, 20.95% oxygen, 0.93% argon, 0.04% carbon dioxide, and small amounts of other gases. Air also contains a variable amount of water vapor, on average around 1% at sea level and 0.4% over the entire atmosphere. Air composition, temperature, and atmospheric pressure vary with altitude, and air suitable for use in photosynthesis by terrestrial plants and breathing of terrestrial animals is found only in Earth's troposphere and in artificial atmospheres. How many layers of atmosphere are there? Okay, so stratification in general air density. Okay, from highest to lowest, the five main layers are exosphere, so that's 700 to 10,000 kilometers in size. Fucking hell. Thermosphere, 80 to 700 kilometers. Mesosphere, which is 50 to 80 kilometers. Stratosphere, which is 12 to 50 kilometers, and troposphere, which is 0 to 12 kilometers. Okay, I guess I was wrong about the magnetosphere and all that bollocks. Okay, major constituents of dry air by volume. Argon, carbon dioxide, neon, helium, methane, krypton, water vapor not included in above dry atmosphere. That's another aspect of the atmosphere that I don't, when it comes to like climate change and global warming, that no one seems to, it seems to have just been completely disregarded completely, because clouds are physical objects. Like when it's cloudy, there's no sun. So, but when there's no clouds, it's sunny. So ergo, they're physical objects, which means that they can physically either block out anything external or they can keep in anything internal. So I wonder if clouds and cloud density has an impact on global warming, on climate change. Okay, consent. So this is on worldatlas.com. Where does the atmosphere end and space begin? Most experts agree that space begins at the point where the orbital dynamic forces are more critical than aerodynamic forces. This is the region where atmosphere alone cannot support spacecraft at suborbital speeds. In the early 1990s, physicist Theodore von Karman estimated the boundary as 50 miles above the sea level and named the imaginary boundary the Karman line. However, the National Oceanic and Atmospheric Administration (NOAA) and the Federation Aeronautica Internationale defined the limit as 62 miles or 100 kilometers above sea level. NASA, US Air Force, and the FAA recognized the boundary as 50 miles. However, NASA Mission Control recognizes the line as 76 miles because it is the point at which atmospheric drag is felt. Can't even agree on that. Okay. Astronauts use a shifting boundary. Yeah. Okay, so the Earth's atmosphere is massive. In the hundreds of thousands. Is it hundreds of thousands? Let's see. 10,000. Thousands, yeah. Okay. So the question is, when you're calculating that atmosphere has a mass about of, hang on a minute, 3/4 of which is within 11 kilometers of the surface. Okay, so the mass of the atmosphere is approximately 5.15 times 10 to the power of 18 kilograms. And 75% of all of that mass is within the first 11 kilometers of the atmosphere. So the lowest lying level, not the highest, so the lowest. And that's astonishing, that is. What's the Earth radius common line at 100 kilometers or of Earth's radius? Actually, yeah, because if you want to work out what the volume, you can work out the mass. So how do you work out the volume of the Earth's atmosphere then? What is the volume of Earth's atmosphere? What is the volume of Earth's atmosphere? Okay, let's go on there. Also going on NASA's website. Okay, Earth fact sheet. Bulk parameters. Mass. Oh, no. Bulk parameters, okay. Orbital parameters, wow. North pole of rotation, terrestrial atmosphere, surface pressure, surface density, scale height, 8.5 kilometers. That's not. Total mass of atmosphere, total mass of hydrosphere. I guess do you need to work out the volume of the Earth's atmosphere, the atmosphere, in order to work out how climate change takes place? Actually, let's leave it there. That's a question for anybody who's watching this. Do you need to work out the Earth the atmosphere, the volume of the Earth's atmosphere, in order to understand how climate change works? And how do you do it? No, wait, yeah. That's a question for you lot. And then, yeah. Shall I leave it there? Yeah, I'll leave it there for now because I've talked about what's been on my mind more than anything, which is about how large is the Earth's atmosphere? How do you calculate the volume of the Earth's atmosphere? What is the elemental composition of the Earth's atmosphere? Does it really make any difference? Yeah. Like, share, subscribe. Let me know what you think, because I want to read your comments, because I want to be able to do my own little, instead of being told and being bombarded with pointless alarmist information or breaking news. I'd rather just find out for myself, really. Thank you.